So welcome everyone with the today's session of NPTEL course Environmental Chemistry. This is the seventh week live session and I am Saptarshi Bose here, a PMRF research scholar from IIT Madras. So basically we will start with few numerical questions. We'll try to solve those. So the first question is, a wastewater is simulated as an ideal solution containing 10 to the power minus 2.5 molar NaHCO3 sodium bicarbonate and 10 to the power minus 3 mole of NH4Cl. So these are the molar concentration you can see, and the utility hopes to remove the nitrogen from the solution by volatilizing NH3 gas, ammonia gas. To prepare for that step, 148 mg per liter of calcium hydroxide lime will be added to raise the pH and convert to NH3. So the now pH before and after the lime addition you have to write down. That's you have to calculate. One more thing you should note that no CaCO3 precipitation or ammonia loss takes place during the lime addition. So these are the conditions and the data. So quickly solve it and write your answer in the chat section. Okay, I got one answer. First answer is D. Okay, Logan, let's go for the solution then. The answer will be A. Correct answer will be A. Please check your process whether it's correct or not. I'll tell you how to solve this. Hope this will help you to understand better. So let's go to the solution. So how we will solve. First, we need to check what are the conditions, the data. So this much NaHCO3 was there, 10 to the power minus 25, and then NH4Cl was given at 148 mg per liter of calcium hydroxide was added, right? So NaHCO3 is 10 to the power minus 2.5 molar, and then NH4Cl, and then calcium hydroxide, right? And you should convert this mg per liter into mole, right? Or moles per liter. Then before the addition, what are the conditions we will write down? And all you know that we are doing all those numericals mostly using vMinTech software. So I will suggest everyone to use this vMinTech software. This will help you to quickly solve these questions. So to give the inputs in the vMinTech, we have to find out first what are my components. So the first component is then sodium, that is the total sodium. This is nothing but 10 to the power minus 2.5 because there is no other sodium source, right? It is not giving sodium, this is not giving sodium, only this is the source of sodium. So how much it will give? Obviously 10 to the power minus 2.5, that's what it has. Like, it cannot give beyond this amount, right? And then what about this hydrogen? See from where we are getting hydrogen. From this place we are getting hydrogen, one hydrogen, right? From one NaHCO3, one sodium bicarbonate, I am getting one sodium. That's why this much 10 to the power minus 2.5 molar. And then from 10 to the power minus 2.5 molar of sodium bicarbonate, I am getting only one hydrogen. Sorry, I am getting 10 to the power minus 2.5 molar of hydrogen. Right? From 1, I am getting 1. From 10 to the power 2.5, I am getting 10 to the power 2.5. Simple calculation, nothing else. And then I will calculate how much carbonate I am getting. This is also 10 to the power minus 2.5, right? From 1, I am getting 1 carbonate. So from 10 to the power minus 2.5, I am getting 10 to the power minus 2.5, right? This is also very easy. And then NH4, yeah, from here also I'm getting 1 only. So from 10 to the power minus 3, I'll get 10 to the power minus 3 mole. And then Cl is 1, and from 10 to the power minus 3, I'm getting 10 to the power minus 3. So this is how we will write. I already discussed these kind of things in the previous sessions also, how you can find out like what is the procedure to find out how much I am getting, like from 1 to 1 or 2 to 1, something like that. So then we will go for this Vmintex software. Will give the inputs. Already you know how to give the inputs. Just drop down and give the inputs of H plus. That is from here. This one 10 to the power minus 2.5. Just write it down. Then uh, other things like chlorine. Write it down and give all the inputs. Right. If you give all the inputs and run the Vmintex, you will get the pH as 8.1. That is our desired pH. And then after lime addition, what is the change we need to take? So what will happen that if you add the lime, additional components will be there. So how much it will be left? Or how much calcium I'll get? 2 into 10 to the power minus 3. Right? 2 into 10 to the power minus 3 calcium ion I'll get. And another thing I am getting from here, this hydroxide, right? So it contains hydrogen, and it is also in the form of hydroxide, or you can see that is hydroxide anion it can give, right? So it will give OH minus. This anion it will give, right? OH minus it will give. And we know when we have to calculate this hydrogen, total hydrogen, we have to subtract that much of hydroxyl uh, ion, right? So that much of hydroxyl ion we need to subtract from the total hydrogen or whatever hydrogen was there. So initially hydrogen concentration was 10 to the power minus 2.5. Now you are subtracting this because that much of hydrogen can be in the form of water, or it can take up this hydrogen, right, to form the water molecules. That's why we are subtracting this. I'm getting this hydrogen concentration value, and then I am giving this input. We are going for the view or edit list. Just edit this one and add this one. Right? Only two things we are changing: this hydrogen and calcium. I'm getting the new pH is 10 to the power 10.92, right? So this is the next question. A raindrop formed in the cloud passes over a smokestack and absorbs 10 to the power minus 5 molar H2SO4. Right? And then the droplet next passes over the cattle feedlot and comes to equilibrium with NH3 of partial pressure, that is 10 to the power minus 10.2 atm. So while remaining in equilibrium with atmospheric carbon dioxide. Now the pH and total dissolved nitrogen of the solution is, you have to find out. Just a minute. Okay, so we'll go for the answer. The answer will be A, option A, that is 5.69 into 2 into 2.08 into 10 to the power minus 5 molar. So we will check how to solve this. So what were the data? So the first one is that it clouds raindrop formed in the cloud passes through smokestack and absorbs 10 to the power minus 5 molar of H2SO4, right? And then it cross over a cattle feedlot and comes to equilibrium with an HP partial pressure that is 10 to the power minus 10.2 atm, right? And then while in remaining in equilibrium with the atmospheric CO2. So it's in the position of equilibrium with atmospheric CO2, that is the one hint, and then the partial pressure of ammonia is given and also how much it was absorbed. So the you need to first take care of the inputs, right? You have to sort out what will be the correct input for Human software. And then what is the concentration of H, or what is the source of H? Is coming from H2SO4. How much? 10 to the power minus 5. See, one thing, from one H2SO4, I am getting 2 H plus ion, right? So from 10 to the power minus 5 molar, I'll get 2 into 10 to the power minus 5 molar, right? This is as simple as that. And then SO4, I am getting only 1 from 1. So from 10 to the power minus 5, I'll get 10 to the power minus 5 molar. Just put the input in the vMinTest software in the component list drop down, then go to the specify gas. So you will get it's in this position, specify gas in the top position. There is option. Go there. First option, choose the specify fixed carbon dioxide partial pressure. This is keep one only. So it is just yeah, in equilibrium with the atmospheric carbon dioxide pressure. So we don't need to change. Just add here and then go for NH3 gas. So good. Next option, choose a gas among the gases, and then you can find this option there from the drop down list, NH3. Just change here only how much it was given, the 10 to the power minus 10.2, right? So 10 to the power minus 10.2 I am writing here. Just go for this add. Run vMintech, you will get the pH is 5.69. So this is easy. Then what you have to do, the next step, then go to equilibrated mass distribution. There only you will find that at the bottom corner, like on the bottom space, there is one thing written, equilibrated mass distribution. So from here you can get how much concentration of NH4 was there. So you will get that much concentration of NH4 or dissolved nitrogen is there. So this is the only source of nitrogen, right? There is no other source of nitrogen. So I can take this value only, and this is totally dissolved, right? 100% dissolved. So there is it is 100% dissolved. Let's take care of it. Nothing softened, nothing precipitated, anything else. That's it. So this is the next question. Two waters at 25 degrees centigrade are in equilibrium with air, and one at pH 9.5, another 6.5. Then the water are mixed in a proportion of 1.5, 1 is to 5, and then assume that carbonate species dominate the acid-base behavior, right? For both the solutions, and no gas transfer occurs when we are mixed with the closed system. The alkalinity and pH of the mixtures are, you have to calculate. Use vMintech software quickly and answer. Okay, I got research from you. Okay, I got your answer. Look, Nathan, and this is the fourth closed system you were saying that is alkalinity will be minus alkalinity will be okay 3.08 and option C, right? That's what you were saying. Okay, okay, yeah. Okay, this is your assignment also. Okay, fine. So let's see what is the answer. So it is showing, please check whether you are right or wrong. Maybe there is some numerical issues. I'll tell you. Maybe I am wrong with this numerical calculation might be. But check the process. Try to do solve with this process and check your answer. That's what I can say. The process is correct, but there might be some numerical mistakes like calculation mistakes. If I have done, please check it. Please try to note it down how I am trying to solve this. First, what you have to do this. First, you have to take. Okay, sorry, I haven't given this screenshot of the Vmintech. Just I am telling, try to note it down. That is, first you have to give the input in the Vmintech software. There is an option like pH, right? pH at fixed pH. Go there, pH on the front page. Go to fixed pH, right? Go to fixed pH and then give this pH value 9.5. Okay, and then go to this equilibrium condition, the specified gas. Go for CO2 gas. You will get this. Just go there, and this was equilibrium with air. Okay, after mixing, it was in a closed system, right? When they are mixed, but when they were separated, that time it was not closed system. So these things you have to take care of. So when we are mixing, then at that time or after that, it's a closed system. But before that, it was an open system. When it was having the pH of 9.5 and 6.5 and all. So you have to take care of your carbon dioxide also. It is equilibrium with carbon dioxide. So go there and equilibrium with only ATM. One, there is nothing to check, nothing to change, and then run the Vim intake. You will find this component list, right, with the concentrations. Vim intake will give all those concentrations. You don't need to get. Just give this input, go to your gas and just specify with carbon dioxide one, then you will get this component list. Then what you have to find out is from the total hydrogen you have to calculate. So how you are getting total hydrogen? From here you are getting to hydrogen, right? From here you are getting, and from here you are getting, right? And also you have to take care of hydroxyl ions also. So add this and then subtract with hydroxyl ion. So you will get, you know how to calculate total hydrogen. That is already done. So from where hydrogen is coming from, this place, and you have to negate this one, right? Then you will get this one. And from where carbonate I am getting, from here I am getting carbonate, right? From here also I am getting carbonate. Just add up these two, you will get this total carbonate, right? Then what is your next step? That is the alkalinity. You know what is the alkalinity formula. So I am not repeating again. So what is the alkalinity formula? How you will get alkalinity? This bicarbonate. Then your this one. You have to take care of your hydrogen also there, and other components if anything is present this carbonate, right? Carbonate can take up two, so twice carbonate. I think you can remember. I am just brushing up your memory. Then from HCO3 also you can write HCO3 because it can take up one hydrogen ion, but not H2CO3 in case of alkalinity, right? It cannot take any more hydrogen, as it can give hydrogen ions, but cannot take hydrogen, right? So similarly, you have to write this alkalinity formula, put the concentration, put the values, you will get total alkalinity from here. Then for pH 6.5, same thing, equilibrium with the air, same, nothing else. Go there, 6.5, write 6.5 there, and then also with the equilibrium of carbon dioxide, you will give this component list. So from here, calculate what is the total hydrogen, total carbonate, and alkalinity, right? This much is done. Then what you have to do, the mixing ratio is 1:5, right? So this alkalinity will be the first alkalinity I'm taking here, this one, right? So the alkalinity I'm taking multiplied by 1, then the next one 1.79 multiplied by 5. This is the ratio 1 is to 5 and divide by 1 plus 5. So this is how we can solve. So we are getting this alkalinity of the mixed water. Then total hydrogen also I'm getting in the same ratio 1 is to 5, right? I'm getting this much, and then carbonate also this much 4.3 into 10 to the power minus 3 molar. Then input this above this calculated, all those if these things are calculated, this one and this one, right? So now you have to calculate this with respect to closed system, not an open system. This up to this point, like you can see, this was a open system. Then we are moving towards the closed system. First, we have calculated what will be the concentration. Then we are changing the system also. So it is then just go there and don't go for the specify gas. Reset this option. Just give the inputs of your hydrogen. This thing, just hydrogen. This one and this one. Give the components input. Don't go for anything gas. No need to go. You will get this list, right? And you will get the pH also there, 9.5. And from here also you can again calculate what is the hydrogen concentration, carbonate concentration, and also alkalinity. So in the similar fashion, you will get this pH is 9.56 and alkalinity is 5 into 5, sorry, 5.064 into 10 to the power minus 3 molar. So we'll go to the next question. In this question number 3, if the system is allowed to equilibrate, like you can take the data from the previous question. If the system is allowed to equilibrate to the atmosphere after mixing, like before it was a closed system, now we are thinking it's an open system after mixing also, then what is the pH of the mixture? Same thing or with a small change? Okay, no problem. Just do it. I'll tell you how to solve. Don't worry. So the answer will be 8.8 pH. So this is a easy question because if you can solve the previous one, then it's not a big deal. Uh, Just a minute. Let's get because okay, thank you. Yes, I'll tell you how to solve this. So what you have to do, like you know what is the total hydrogen there and total carbonate there, right? That you already have calculated, right? This is the total hydrogen and this is the total carbonate. Already you know from the previous question, right? That much you have to give the input. And the components give the input there in the component list. Just drop down that, uh, put 3.516 millimolar there in case of hydrogen, H plus ions, then carbonate ions. There, write 4.3 millimolar there, and go to specify carbon dioxide gas. Simple thing, and then go for this the multiplier of or multiple of 1 of the partial pressure, right? So it is with equilibrium with carbon dioxide, atmospheric carbon dioxide, no need to change anything. It is already given there. Just write it 1, the 1 multiple of 1, and add here, run vmintex, you will get pH 8.88. So this is as simple as that. And then, like, is there anything else it was asking for? Okay, no. Yeah, these things you can get this pH is 8.8, right? Nothing else. And then we will go to the next question. So from the previous question, you have to take help. This is question number 4. After the equilibrium has reached with the atmosphere, 1 millimolar of H2SO4 is added into the solution. So this is the consequent questions. From that previous question only, we are continuing. So now the condition is changed again after reaching the equilibrium with the atmosphere, which was the last step in our question number 4. Then I have added 1 millimolar of H2SO4 into the solution to decrease the pH. Right. So now what is the final pH? Okay, we'll go for the solution. So the final pH will be 6.55, right? So this will be 6.55. And this is the way we will try to solve this. So the last position where we were, it was something like that, right? It was something like that. See, this was the condition 8.55 from the previous question only. This is the list of the components with their concentrations, right? This is the concentrations. From here, the same thing is here, nothing else, 8.885 from the previous question only. These are the concentrations. You need to find this total hydrogen. You can find what is the total hydrogen, right? I already told you, just you have to do the addition. From here we am getting 2, from here I am getting 1 only. Then you will get 4.7 millimolar. And then also carbonate, you are getting is 4.89 millimolar, right? Then go to the reset button. Just back from this page, go to the reset button, press the reset button, it will be resetted. Then add this H2SO4, right? Then you have added this H2SO4, so you have to take care of this H2SO4, which will actually bring down your pH. So from you had 4.7 millimolar of hydrogen ion already. Now you have added H2SO4 of 1 millimolar, right? And 1 millimolar of H2SO4 will give you 2 millimolar of hydrogen ions, right? So one H2SO4 give you 2 hydrogen ions. So 1 millimolar will give you 2 millimolar hydrogen ions. So previously it was 4.7, then add 2, right? Nothing else. It's very simple. So now it is 6.7 millimolar. Go there. After going there, just and another thing we are getting, not only this hydrogen, we are getting, this is already fixed 4.89, no change. Nothing is coming from H2SO4, no carbonate we am getting. So I am getting another component, that's the SO4 2 minus sulfur ions. So how to write this 1 millimolar? It will be 1 only, because from 1 H2SO4 I am getting only 1 SO4 2 minus ions. So just keep the inputs here, component names, go 3 components. You need to give the concentrations here 10. This is a closed system, right? Yeah, this is a closed system, not in equilibrium with atmosphere. So don't need to go for the specified gas. No need to go there. Just run the Vim intake and you will get the pH as 6.55. So this is our final pH. So this is also a very easy question. Let's go to the next one. A solution is at pH 8.35 and has reached equilibrium with the atmosphere. Now place this solution in the closed system that no gas liquid exchange occurs. Then the concentration of H2SO4 mole per liter that must be added to lower the pH to 6 is, you have to calculate. Okay, we'll go for the solution, not wait anymore. So the answer will be D, 4.55 into 10 to the power minus 4 molar. So this is how we will solve. First, we have to fix the pH at 8.35, right? This is the 8.35 pH is given, and it is equilibrium with the atmosphere. It's a closed system. Like when it was the solution, then it was open system, equilibrium with its atmosphere. Now placed in a solution in a closed system. Now it's a closed system when you are adding this H2SO solution. Okay, then the pH should be 6, from 8.5 to 6, right? And then specify the gas as a multiple of 1 atmosphere, because initially it was equilibrium with the air. It was an open system, not a closed system initially. Run the Vim intake and you will get this concentration with respect to the components. Go to this Excel, convert it into Excel. There is an option you will find in that page only, in that interface only. Then you can calculate what is the total carbonate and total hydrogen, right? So the same thing I already told you, like how to find out this total hydrogen, total carbonate. So the total carbonate we are getting 0.00135 molar, and then hydrogen I'm also getting 0.00135 molar. Please check whether these calculations are correct or not. So then reset this Vim intake. You have to give input again. That's why I'm resetting the whole program. Then go to the input section, write down H, the from the drop down select that H plus ions, total hydrogen ions, keep that value, keep this value, and then also carbonate, give this value 0.0035, right? And fix the pH at 6, because that is our current pH. So if you fix the pH at 6, first go to that option only, the pH option, the first interface only you will get this. First fix this pH 6. Don't keep it that calculate from the mass balance. Then you will get a wrong answer or you will not get the proper uh, outcomes. So that will be the problem. So all please be careful, because in the previous questions, like in the previous live sessions, when we were trying to solve the questions, that time we are selecting some options like calculate from the mass balance or something like that. But in this session only, from this particular few questions, I am fixing the pH. So please be careful with this, because if you don't fix the pH, then you will get a different kind of answer, which will be not the correct one. So fix the pH at 6, then run Vim intake. So this is very, very important from our sessions, like 7 sessions. I'm doing similar kind of questions, right? So then run this Vim intake, you will get this list. And then click this equilibrated mass distribution. At the bottom, you will find this. There is an option called equilibrated mass distribution. If you click this option, you will get this table. This was the original table, the final the initial interface, right? After running this vMenter software, you will get the simple interface. Then there is option just below this table only, this table only option, that is called equilibrated mass distribution. And if you just click there, it will give you the total concentration of the components, whether it's a dissolved form or precipitated form, it will add up. So in this way, you can just add up very quickly. You don't need to calculate uh, by yourself or manually. So this is the easiest way to get the data. So you don't need to write it down and then solve and then calculate. So this is the usefulness of this table, the equilibrated mass distribution. So from here I am getting this is that much of H plus ions, 2.289, right, into 10 to the power minus 3, 2.289 into 10 to the power minus 3. This is the now concentration, right, of the H plus ions. And initially, what was the concentration of H plus ions? It was the initial concentration, right? 0.00135. So it was before the addition of H2. So what we have added H2SO4, right? Yeah, H2SO4, not HCl. So before the addition of H2SO4, that was the H plus ions concentration. Okay, then after the H2SO4 addition, this is the concentration. So what is the change in total H plus ion concentration? Nothing but this one minus the previous one before H2SO4. So 1.35 into 10 to the power minus 3, and I am getting 0.939 into 10 to the power minus 3 molar, right? And then you have to divide it by 2 to get how much is the molar concentration of your H2SO4. Why? Simple thing. From one H2SO4, I am getting how much H plus ions? 2 H plus ions, right? 2 H plus ions. From one H2SO4, I am getting 2 H plus ions, right? So if you want to go in the backward direction, right? You now try to find what is the concentration of H2SO4. Then what you have to do? You have to divide, right? The total H plus concentration divided by 2. Then you will get that much of H2SO4 you actually need, or that is the concentration of H2SO4 you actually need, right? So that's why we are dividing, not multiplying. So if I want to know how much H plus ions I am getting from a certain quantity of H2SO4, then I will multiply. But when I am trying to know what is the concentration of H2SO4 from my known H plus concentration, then I will just divide. So that is the fundamental thing. That's why dividing, getting 4.69 into 10 to the power minus 4 molar. So this is the next question. Consider a solution having pH of 8, alkalinity of 50 mg per liter as CaCO3. So this solution is placed in a container having partial pressure of carbon dioxide gas as 1 atm, allowed to equilibrate with the carbon dioxide gas. Then the pH of the solution in the container is, you have to write. It's a little bit tricky question, nothing, only the like some puzzle kind of question. Okay, we'll go for the solution. So the answer is 4.8. How we will try to solve this? So go V main tech, again fix the pH as 8, right? So pH was 8 and the alkalinity is given. Specify the alkalinity. There is an option to specify the alkalinity. Just go this in the top section, you will find there is an option called specify the alkalinity, right? So at that position, specify your alkalinity with 50 mg per liter as CaCO2. So this is in the top position, not in this section. Not in this. In the top section, you will find one option called specify alkalinity. Specify it at 50 mg per liter as CaCO3, then run a vMatrix software. So what you will get? You will get all the concentrations, right? You will got all the concentrations. From here, calculate what is the total concentration of H plus ions, right? And what is the total concentration of CO3 2 minus ions. So if you just calculate here, you will get 1.03038 millimolar. I'm getting total hydrogen concentration, and total carbonate ion concentration is 1.0145475 millimolar. So you just add up from where I'm getting one hydrogen, and just you will get this thing. Then reset V Vmaintech again, because you have to give the inputs again. So I'll go to this reset V Vmaintech, then again add total hydrogen and total carbonate, and calculate the concentration, right? And there also you need to specify the carbon dioxide, because it might seem you that is a closed system, but actually it's not a closed, like it's a closed system in terms of the we are using container, but there is a similarity between this system and the atmospheric system, a small similarity, because in this container we are having carbon dioxide with a partial pressure of 1 atmosphere, right? So it has the similarity with the open system. It's actually not an open system, it's a closed container, but that is filled with carbon dioxide and with that partial pressure, 1 atm partial pressure. So just go there, choose a gas among the gases from this option only, not from this option. From this option, I'm going to drop down as CO2, and here only 1 atm pressure. Just add here, then run the Ventec, you will get the pH as 4.815, right? So this is your final pH, 4.815. So this is our 8th question. So in the question 7, after the equilibrium of the solution with carbon dioxide gas present in the container has been reached, so initial pH was 8 and then the final pH was 4.8, right? So this means that CO2 is coming into the solution, right? When the carbon dioxide mixes with the solution, it converts into H2CO3 acid, so which reduces the pH of the solution, right? So this is the thing, that when it is coming into this H2CO3, like final, from initial pH to final pH, it is coming into this solution. So again, it will come into the solution. So that is our thing. So hope everything is clear. So thank you everyone. Thank you for joining today's session. Hope we will meet in the next Saturday at the same time. Thank you everyone. You may leave now.